Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Mukul Rothy's fascinating blog post, How I Wrote My Own Proper Programming Language. A deep dive into building the Bolt compiler. It's a really exciting project.
Yeah, I've been looking forward to this. The title alone is intriguing. So what's the core idea behind this blog post series?
Essentially, it's a practical guide to building a full-fledged, concurrent, object-oriented programming language. Not just a toy language with basic arithmetic. He calls it Bolt, and it's designed to be more than just a simple exercise. It's ambitious.
Ambitious is an understatement. So what makes Bolt stand out from other build-your-own-language tutorials? I'm particularly interested in the concurrency aspect.
Right. That's a key differentiator. Most tutorials stick to simple languages. Bolt, however, tackles objects, inheritance, method overriding, concurrency, something rarely covered in such tutorials, and even generics, allowing things like linked list. It's a comprehensive undertaking.
Wow, and it compiles to LLVM, right? That's a big deal. That's used by languages like C, C++, Swift, and Rust.
Exactly. That's a huge accomplishment. Leveraging LLVM gives Bolt access to powerful optimizations already present in established compilers. The author even mentions this post was number 2 on Hacker News.
That's impressive. But why would someone even want to build their own programming language? Seems like a monumental task.
The author argues it's about building better mental models. Learning multiple languages reveals common themes. But creating your own forces you to think critically about language design. It's not just about the fun or the coolness factor, although those are definitely there. It's about deeper understanding.
I see. So it's a journey of learning by doing. He uses a really interesting analogy, comparing the compiler process to a 19th century telegraph operator translating speech into Morse code. Clever.
Absolutely. He breaks down the compiler stages: lexing, parsing, type checking, and translation, using that analogy. It makes the complex process much more accessible. He even talks about the runtime environment, which is like the operator's tools for tapping out the Morse code.
And the different compiler approaches, interpreted versus compiled, and the role of LLVMIR as an intermediary. It's all very well explained. What about the type system? That sounds particularly interesting.
Yes, the type checker is a crucial part. In the analogy, it's like the operator checking grammar. Bolt uses a unique approach with both traditional types and capabilities to handle data races. He even mentions a dissertation exploring this in more detail.
2 type-checking phases. That's unusual. I wonder if that adds significant overhead. Perhaps a trade-off for the enhanced safety?
That's a great point. It's definitely a trade-off. The added complexity might impact performance, but the enhanced safety and prevention of data races could be worth it, especially in concurrent programming. It's a fascinating design choice.
So in summary, this blog post series isn't just about building a compiler. It's about gaining a deeper understanding of programming language design, concurrency, and the intricacies of compiler construction. It's a valuable resource for anyone interested in these topics.
Precisely. It's a highly practical and insightful guide, and the author's enthusiasm is infectious. He even shares the challenges he faced, making the whole process feel relatable. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of compiler design. Have a great day.
Bye-bye.